Now we have serialization working with our JSON script. It's time to sort of change pace a little bit, and we're going to go for our binary serialization. So this is where we take our saved game data, which is going to be in the same format when we in memory. So we're going to use board, but instead of instead of using board to serialize out to JSON, we're going to write our own serializer, which is going to save everything in binary format. So the binary format is going to be specific to our game and not to any other game. So you're going to have to change this around for your games, but I'll show you the technique that we can go through to do that for the chess game, and maybe you can apply that to your own projects. So as usual, all of this starts after the fade. Okay, so back to our chess serializer we go, and we have our get save location for our JSON file, but we're going to change this up a little bit, and we're going to use a different save location for our binary file. So it's going to be basically copy and paste for this, I'm afraid. So we're going to copy and paste that. So instead of save location, we're going to change that to save location binary. And we're going to change that from chess.json to chess.dat. But it's the exact same location. It's inside the user's persistent data path, which is specific to your application, company, all that kind of stuff. And it's the exact same location. Our load game, we're also going to have a public board load game binary, which we're going to return null just now because we're going to handle that in the next video. And then we're going to have public void save game binary, which is going to do our save game. So this is what we're going to concentrate on just now. And really, a binary format, let's have a look at what do we have here on the old internet. So we have this interchange file format. This was created, 31 years ago. It's the IFF standard has been used by a whole bunch of different developers. I think 3D Studio Max still uses it, but it's based on chunks, and each chunk has a particular rules that define it. So there's this gives an example of how you can encode that. But the most popular one is the interchange file format, which was created by Electronic Arts and Commodore, 31 odd years ago. So this has been around for forever. So our file, what we're going to do is we're going to write out a header, and that header is going to contain the file type, and then number of items, which is going to be our chess pieces, and then it's going to be the body, which is just going to contain the what's the word I'm looking for? The piece type, and then the location. So that's the X coordinate, and then the Y coordinate. And this whole thing here, this is actually going to be repeating. So this is actually going to repeat all through the code. So our file type, we're just going to call some arbitrary value. We're going to call it chess with only one S. It's usually a chunk is 4 letters. The other one is the where's all my data file format. What file? Here we go. So the Doom mod is a common format package used for video game Doom on Hell. It stands for where's all the data, and it's basically the same idea. I wonder if it's got an example of it. Probably not. No, of course not. Anyway, we're going to define the header, which is going to give our file type, so we know it's the right file. So when we read the first 4 characters in, then we know it's a valid file. The next thing is going to be the number of items. The number of items is just the number of pieces. The number of items is going to be an integer. So the file type is going to be 4 times characters. And our body, our piece type is 1 character. And then that's a floating point number. And then that's a floating point number. Okay, so this is our record, and this is our number of records. So so our number of records is going to be 32 because we have 32 pieces on a board for the default game, and then the body is the records repeated. So each record is going to be one character plus 1 float plus 1 float. A float is 4 bytes, which means that our each record is 9 bytes long. So by quick calculation, 4 characters, number of integer, which is also 4 bytes. Let's just see if this is, we get the calculation right. So our header is going to be 8 bytes. Because that's 4 characters there plus 4 for our number of records, our integer number of records, that's 4 bytes. And then we have 9 repeated plus 9 times 32. So 9 times 32 is 288 plus 8, which is 296. So it's going to be about 296 bytes file size. Okay, so to compare that, our JSON file, where's our JSON file? Our JSON file is 1384 bytes. Okay, so that is going to be 1384. So it's going to be about 20% of the size, so a fifth of the size of the file that we already have. So it saves space in disk, and also, again, when we look at our JSON file, I can read that and I can change these values, whereas it's difficult to understand what the file format is unless you know it. So I'm going to leave that here just now. So if you just want to pause that, just sort of let that sort of sink in just now. This is what we're sort of going to achieve here. So, okay, if our full path get the binary location. So if the file exists, delete it. Because we don't want any overruns or anything in there. So I guess, I mean, because we know the size of this, we could, sorry, I'm leaning in that again. Because we know the size of this, we could actually just create a buffer in memory, but I'm not going to do that. I'm just going to write out to the file. So I'm going to use a stream, and I'm going to use a binary writer. And so what I want to do is I want to use using and wrap everything around it. And the reason why I want to use using is because it does all the dispose and the flush and all that kind of stuff for me, and I don't need to worry about any of this external code. So the using So that's me opening a stream to the file. So I'm opening this file for write. I want to write to this file, and then I want to use that's good enough, and then I can access it and I can read things in from it. But to make it easier, there's different writers and reader classes, and I'm going to use a binary writer to do that for me. So using binary writer. And that takes a stream as its parameter, and the stream that it takes is going to be the one that we just opened to write to. And the reason why I want to use the binary writer is because it's got a whole bunch of functions, well actually overloaded functions, that allow me to write these values out to disk. So one of the things I want to write out, for example, is I want to write out 4 characters to represent the header. So write the header. So, oh, I don't know why I put a semicolon there. Write the header. So I want to write out, and I want to write out chess. But I want to write it as a character array. I don't want to write out a string. I just want to write out chess as the character array. And then I want to write out how many records I am saving. And what records am I saving? Well, because it's board, if I go back to board here, I have my list of pieces. So I want to write out board.pieces.count. And the reason why I do that is because I need to know how many records I have in this file. And this is key to writing out binary information. You don't write out the binary information and then write out at the very end, oh, I wrote 5 files, I wrote 5 records. How are you going to get to that 5 number? There's no way you know how many records you've written out unless you put the records up front. Those of you who are familiar with Pascal will recognize this from character strings, where they have the number of characters at the very first character in the array of characters. Sorry. And then the rest of it is just the string itself. So we always write the number of items out first when we write a binary file. And now it's just a matter of going through all the pieces and writing those values out to the file. So we're going to do for each piece P in board.pieces, because again we don't care where these positions are, we just care where they are in disk. And then I'm going to do w.write and then p.type, and I only want the character. I don't want anything else. I don't want the string, I just want the character. So I'm going to choose the first character of that type, which is going to be the 0th element in our string. Remember, if I have a string called Sloan, then our elements are listed as 0, 1, 2, 3, 4. So the 4th element is n, or well, rather the 5th element is indexed as 4. And then I want to write out the coordinates now. Because it's an x and it's a vector 2, I'm just going to write them out as separate components. So I need to know the order that they're going to get written out to, because then I'm going to have to duplicate that in the read in, which we're going to do in the next video. p.position.x, and then I do write p.position.y. So this is our 8-byte header, which is this here, write out a header. So I'm going to cut that there, and paste that there. So write out a header, which is a file type, which is 4 characters, and the number of records, which is this here. So that's the number of records. And then for each record, I am going to write out this. So for each record, I write out those values there. And because, remember, that's 296 bytes. So I reckon our file size should be about 296 bytes. So our saved binary file, we check to see if it exists. If it does exist, we delete it. We then open it up for writing, which gives us access to that particular file. And then in order to format it correctly, we use this binary writer class. And then that gives us access to these methods here, the write methods, that allow us to write out information to that in the format of a binary file. Now, although we're writing out CHES, we're actually writing out the binary version of that. We're not writing a text file, we're writing binary. So we're going to use the toChar array for that. Okay, so that's us there. So now we need to, is this a public? This is public, void save game binary. Okay, so now we go back to our Unity here, and I have my button, and I'm going to duplicate that again, and I'm going to change this to our save game. So I need to add that to here. So go back to debug. So we have a load game here, which is loaded in from, excuse me, loaded in from disk. So I'm going to change this to board current game. And then I'm going to use these values instead. Okay, so that's all I've done, is I've just made this generalized, because what I want to do is I want to load this game in, then I want to save the binary data out. So I want to be able to store that in a variable that I've got access to inside this class. So I want to create this field here. So I'm going to create a new public method, save binary, and then it's going to be get component board renderer. No, it's not board renderer. It is serializer dot save game binary, and then it is current game. Okay. And now I'm going to change the text on here to read save binary. And then my event, again, is going to be changed to save binary. Okay, so I made that the current, and I use that to load in the current game if I want to create it. Excuse me, if I want to load the game, then I make that the current game, then initialize it, and then if I want to save the binary, I need to load in the game first of all and then save current game. Okay. Alright, moment of truth. Press play. So I load in my game. So now my game is in here, and then when I click on save binary, that saves it to disk. And if I go to my disk, and you'll see that we now have chess.dat. Now if I open this up in a binary editor, can I zoom in here? Maybe not. Oh, it'd be nice if I could zoom in. Why would you let me zoom in? View. Oh, here we go. Bytes per row. There we go. Let's make this fixed career new 18. There we go. Okay, that's a bigger size. So you see now that we have our first 4 bytes, which is chess, and then we have this value here. Now, I don't want to go into big endian and little endian, but basically this is little endian. So we have the little end is first, which means the smallest value is first. So this is a hexadecimal value. And those of you who don't know hexadecimal, I can assure you that 20 in hexadecimal is 32. So we have our 32 pieces here. And then the rest of it is, this is a pollen. This is its x coordinate. This is its y coordinate, and so on. And it should be on disk (296 bytes). So there we have it. We have our save game saved, and we know exactly the size of the file. So it is, it's 1 kilobyte on disk, which is still half the size of our JSON file on disk. And that's binary serialization. Just as long as you know what you're writing out, and when we look at the deserialization next, you'll see that we take that exact same format and we bring it back out and we reconstitute the data from that. So yeah, thank you very much for watching. Thank you for your time. It's I know time's important. If you like, thumbs up. If you didn't like, thumbs down, and let me know in the comments below. And until next time, thank you very much again. Thank you. Bye.